Guys, in this video we're going to begin our exploration of larger systems of linear equations. And so we've seen two equations having two variables. In this video we're going to take a look at three equations and three variables and just kind of make a relation between the two and see how they're similar, how they're different. So the first thing you'll notice is that we do have three equations and three variables in this case, and so that's the primary difference. But in terms of similarities, what we're trying to do is find an ordered triple, is what we're going to call this here. So I'm going to underline this as it is vocabulary. An ordered triple x comma y comma z that when it's substituted in for x, y, and z respectively into any of these equations would make any of them true. So when we talk about solutions of a system, it's a point that when you substitute it into any equation would satisfy all of them. If it were to fail on any one of these three, then it wouldn't be considered to be a solution to the system. So what we're going to do here is we're just going to check this ordered triple to see if it is a solution. And so what I'm going to do here is I'm going to write a 1 here, as in this is my first equation. And what we're going to do is we're going to test. We're going to test this point, -1, 1, and 3. So recommendations I have is when you do your test, if you're going to make a substitution, you should take out your variable values for which we're substituting values in for and replace them with blank parentheses. So we would see here that our x value has a value of -1, our y is a 1, and our z is a 3. Let's see if this even satisfies the first equation. So multiplying here, I get -3 minus 1 plus 3 equals -1. And so we would get -4 plus 3 is -1. -1 equals -1. Now, just because it works out here, I'm going to put a little check mark right here, boom, doesn't mean that it's a solution to the system. Remember, we have to check all possible equations to see that it satisfies all of our equations. So 3 times our input plus 2 times our input minus 5 times our input is equal to -16 for our second equation. So we're going to put in, again, our -1, 1, and a 3, and let's go explore this. We'd get -3 plus 2 minus 15 equals -16. And to move on with this, here we would get a -1. So -1 minus 15 equals -16. Last time I checked, -16 is equal to -16. So this ordered triple does satisfy the second equation. Let's go ahead and chase after then our third equation here. And so this was 3x plus 3y plus 2z. So we would have 3 input plus 3y input plus 2z input equals potentially 6. And again, let's plug in this ordered triple that we suspect as being a solution here. We want to be able to check our work. So I get -3, a +3, a +6 equals 6, and these two terms would cancel, leaving a 6 equals 6. So just to be clear, this means that this must be a solution, but not just to any of the three equations, but solution to the system of equations. That is, it satisfies all possible solutions in the system. Now, if you were to run into a situation where you plug this ordered triple in, say for this second system here, and it didn't work, you don't have to test the other two equations just because we would know at that point it's not a solution to the system. So I would love for you to try to test this -1, 0, and 1 into these equations over here and make a determination. Do you think it's a solution to the system or not a solution to the system? Cheers.